Okay, part 3. Let's hope that there is no more interruptions. Right? So we can get through these notes and move forward. So here we are, the next section over graphing. There will be a couple of labs where we will do graphing. And again, just because you're not here with me doesn't mean you're not going to do the lab work, the paperwork that goes along with it. I know it seems like, oh, that's easy cheesy, but it frustrates me. I get furious, angry when I'm asked, well, Miss Munson, which part goes on, what variable goes on the X or the Y? Well, my gosh. Some of us act like this is so easy cheesy, but then you ask me those kind of simple questions. So I get angry. So let's look at this. Scientists collect data from experiments to help them solve problems or gather information about an event. Data collected is typically organized into tables, charts, and graphs to make that data easier to read and interpret. Alrighty. Graphs are used to organize observations or data. Graphs make it easier. I mean, it's like the same thing. You're good. To analyze, right? And predict trends. The 3 most common types of graphs are line graphs, bar graphs, and pie graphs. Line graphs. A line graph is uses plotted points and lines to show relationship between the variables. Line graphs are often used to show change over time. Now, bar graphs, it says here, compares data using bars of different heights and lengths, right? And then a pie graph represents the percent of a whole. Okay? We use and we look at a lot of graphs here in physics, mainly line graphs. It says here that, as a quick reminder, the independent variable represents it's represented on the x-axis, and the dependent variable is on the y-axis. The independent variable is a variable that the experimenter actually manipulates or changes. The dependent variable, which is on the y, is a variable that is measured or counted or observed as a result of the independent variable being changed. A data table organizes the data into rows and columns. When you analyze graphs or data tables, always make sure you read the title. When it comes to the next unit, Unit 2, we're going to be using graphs and looking at them. Make sure you read the title. Makes a huge difference of what we're talking about. And the labels. Okay, turn the page. Says here, one way to remember, and I know some of you have already seen this and heard it, dry mix. Dry mix. What does dry mix stand for? Dry. Dry itself stands for the dependent responding y-axis. The mix stands for the manipulated independent, x-axis. Okay? So next part here, x-axis contains, we just said it, the independent, and the y-axis contains the dependent variable. Don't forget, we also have our control group, which is like, quote unquote, the normal conditions. It's when the variable they manipulate it and change. It's whenever they have the normal conditions for that variable. They just take away what they're going to manipulate or change. They're not going to change it. They're going to leave it alone. They're going to leave it normal, leave it alone as is. Okay? A couple more things that we need to talk about. Super important. Next one. Talks a little bit, we just said about dry mix. We're going to look at that right here in just a moment. First, though, I want to skip and go down here to slope. You should know and have from math class, right? Slope is the rise over run. The steeper the slope, or the steeper the line, the larger the slope. What we do need to know, this word, super important, is an inverse relationship. What does an inverse graph look like? Okay, we definitely need to know that. I'm going to use and throw out that word pretty much all school year long. Inverse graph and a direct relationship graph. Okay, inverse relationship and a direct relationship. They're two different graphs and they look a certain way. Now, an inverse graph, the line actually points downward. Oops. I misspelling. Showing us that one variable increases and the other variable decreases. Direct relationship was where the line points upward, showing that when one variable increases, the other variable increases. So inverse is opposite, direct is the same. Inverse, it increases, decreases. The variable increases, is direct. Let's go ahead and draw out what it would look like. So here's what I wanted to show you. So that way you can see it. So an inverse relationship is a downward slope, like this. Okay? When one goes up, the other goes down. When one goes down, the other variable goes up. A direct relationship is an upward, like this. When one goes up, the other goes up. Okay? And so you will hear me using those words throughout. Says here, I'm just going to go ahead and show a couple of things when it comes to graphing, because we will have some graphing to do. When we have a graph, there's a few things that you must do on all graphs. All graphs must have a title. All right. You don't have a title on your graph, I'm going to take off points. The next thing is you need to have some labels. You need to label the y-axis. So make sure that you label it over here. Oops, sorry. You label it over here. Okay? Label the x and y axis. It must be labeled. The next thing is, I've seen graphs where people just start drawing lines. What do you mean? How are you getting the lines? Okay, I've seen some students just start throwing out little lines over here. That's it. They just draw out the little lines. What the heck? Are you going by ones? Are you going by tens? How are you? Are you going by twos? They do their lines over here. I do not know what you're doing. So you must indicate. Here we go. Give me something. Now, I'm going to stop here for a moment real quick because SI units are important. Either, number one, you have the units here. 0 to, what are we talking about? Centimeters? Millimeters? What are we talking about? Or, I've seen some students over here, they might write distance. And then in parentheses, they put in here meters. So they're meaning that those tick marks is 2 meters, 4 meters, 6 meters, 8 meters, and I'm okay with that. But somehow I need the unit. Yes, there's not a unit behind this number, but it's indicated over here because you label this y-axis. I need a label on the x-axis. I need the tick marks, and I need you to label those tick marks. Give me a unit either behind the number or in the label. If not, you're going to lose points. Here, you're given the information here now, correct? So that way, when I take off points later, I'm going to go back and say, well, on unit 1, I told you. Let's look at a couple more things here that it's super important. One thing is, everyone got map pencils. And in those map pencils, if I ask you on your notes or on a homework assignment to color it and to do the, or a lab, to do it in green, then I expect your line graph to be in green. If I ask you to do it in yellow, I'm expecting it to be in yellow. So printing it out and having your map pencil stuff there to color it in correctly is going to be the best bet for you. Okay? But you need to make sure you use the correct colors that I ask you. Okay? And believe me, we will be using colors for throughout the school year. I'm going to go ahead and stop there for this page. We're not done yet. And I'm going to leave this right here. You need to go ahead, read this, and you need to practice on your own. If you have a question, we can come back to this later on and go over it. Okay, but you need to practice. I know you think it's easy cheesy, but when it comes down to it, hopefully you have no problem labeling what is the independent and dependent, which one is X, which one is Y. Okay? Turn the page. We are getting to the almost done point, so. Next page here goes through a little bit of the just scientific method, right? It's like you do it in every science class. What is a scientific method? It's a process that is used to find answers to questions. Is there only one scientific method to follow? No. There are several versions of the scientific method. Some versions have, it says here, more steps, while other versions only have a few steps. However, they all begin with the identification of the problem or question. To be answered based on observations. Of the world around them and provide an organized method for conducting and analyzing that experiment. What is a hypothesis? A hypothesis, yes, is that educated guess based on observations and your knowledge of that topic. What is the data? The data is that information that's gathered during that experiment. So here is just an outline of a general scientific method process. It doesn't always have to be this way because you can rearrange it. But like it says here, we're always going to start off with identifying the problem. Then after that, we're going to form some type of hypothesis. Then we need to come up and think about or create some type of experiment. Then you need to do the experiment. Okay? At the end of the semester, you're going to have an experiment that's going to count as your semester exam grade. I'm going to tell you the problem, all right? And you're pretty much going to have to come up with the rest on your own. Physics is a little bit more like that. You kind of come up with how to do it on your own. Chemistry, last year in chemistry, you probably just sat there and read the papers and did step by step. Here, I don't have all the steps there for you. I want you to think outside of the box on how are you going to come up with the experiment and do that experiment to come up with your answers to solve the problem. The next part, analyze that data. And from analyzing that data, you can go a couple of different ways. Does your data and observation from the experiment support your hypothesis? Well, if you're going to answer yes, then at that point, it looks like you might be done and you can communicate your results. And when you're giving me results and I'm asking you for a conclusion, I'm looking for your data to be included into your results. If any of us are going to go past this class and you're doing experiments, then you need to make sure that you always include data into your results. Don't just tell me what happened. This happened and my data indicated and my results indicated that my hypothesis was correct. Or what happens if it's incorrect and it doesn't answer that question? Well, in that case, we need to go ahead and we need to modify, maybe come up with some different types of steps, change it if you have to, or just change a little bit, and then go back, do the experiment again, analyze the results, and then maybe you're done. If not, you go back and do it again. Turn the page. Next page here is really kind of a few questions. Highlight. Oh, you have a highlighter. Great. The hypotheses that are testable. Men have fewer driving accidents than women. Can that be testable? Yeah, you can go and get data. The word testable means that there is data somewhere. Somewhere we can find data. Could we go and look at all of Galveston County and pull up all of the driving accidents that occurred, and we can compare the amount of men to women? Yes, we could. Bacterial growth increases exponentially as temperature increases. Is there data? Okay, here in physics, we use a lot of quantitative data. Okay, in chemistry, you used a lot of qualitative data. Now, this quantitative data is going to give me numerical number results. Bacterial growth. Can I count out bacteria? Well, those suckers are so small. How do you? Yes, you can count them out. Believe me, that's what I used to do in labs. So bacterial growth, we can count out. If we can count and get a number, then that means that it's testable. A fish's ability to taste food is affected by the clarity of the aquarium water. What? How many of you have good communication skills with fishes? I don't know about you, but I don't. I have not seen any fishes communicate their ability to taste the food due to how clear their aquarium water is. I'm going to have to give that one a big no. Don't highlight it. Tadpoles fear carnivorous insect. Whenever they use that word fear, automatically forget it. That's not testable. Okay? Fear. The number of times a dog wags its tail indicates how content the dog is. Well, the number of times, there goes, okay, well, we can go ahead and number of times, there's a number. But can I indicate, here's a word that we need to, content. When you see some words and you need to ask yourself, does it have to do with like emotions and feelings? If it does, then that is not you cannot test that. It's not testable. A dog's feelings of content and happiness, the tadpole's fear, I can't figure that out. I can't. There's no testable data off of that. A student is able to wear green. Where's green? Happier? Again, there goes that emotion, that feelings. That's just ridiculous. I cannot test it. Now that I said those words, hopefully your brain is thinking a little. Hopefully you come back over here and you say, but Miss Munson, while you say that and you give me these words of feelings and emotion, I look over here and I really don't see the words that indicate feelings or emotion. I like that. Hopefully that's what your brain was going. I really wish we can be one-on-one in class so we can talk like this and just talk out some of these things that are going through your head and that are going through my head. Because as we verbally talk them out loud, then we're able to get answers. We start getting those aha moments. A fish's ability to taste. I could not figure out its taste. If they were to change this and say the fish's amount he eats or she eats, or the fish's amount that is eaten or eats in the aquarium is due or affected by the clarity of the water. Now I can go ahead and I can highlight that. Okay? Has nothing to do with about how it tastes to the fish, because I cannot get that communication across with the fish. But how much it eats during clean water versus dirty water, absolutely, I can test that. I can put certain amount of little fish pebble foods, I don't know, and I can see how much is left over. Okay? So I like that question. So you've got questions here. Questions 2, questions 3 to answer. Okay? Last part here, and then we can be done with Unit 1 notes. Theory is based on natural and physical phenomena that are capable of being tested by multiple independent researchers. Theories are well established and highly reliable explanations, but can change due to new areas of science and new technologies being developed. Let me give you an example right here. There's a theory right now with this coronavirus that if you or a person has already been affected, they've got the antibodies to fight the coronavirus in their serum. Okay? And if we were to pull out their blood, separate the serum, give them their blood back, we can use that serum, this is a theory, right, to go ahead and treat the person. It's being testable. It's being tested right now currently multiple times by independent doctors all over the U.S. and world right now currently. Now, the theories are well established. Why is it well established? Well, believe it or not, we already do this process for other things. Okay? Let's say if you have very low platelets, We'll pull your serum from somebody else and give it to you. We do that therapy where we get the serum from someone else who has the antibodies and give it to another person. So it's already well established because we do this already for other things. But the new COVID-19, we're trying to see if we can do it, but due to change, meaning in the next year from now or 6 years from now, we might come up with something else and figure something else about this. So this theory may be out the window. Who knows? Now we get to a law, which is a statement based on repeated experimental observations, but will always apply under the same conditions. We're going to go over some of these laws: Coulomb's laws, Newton's laws, universal law of gravitation. But at this moment, we cannot say that plasma therapy from somebody who was already exposed is going to be always guaranteed useful for another patient. It's not a law. It's a theory, and we use it, and we have well-established data for other viruses and stuff, bacteria. But as of now, that is definitely not a law because it will change, and it can change once we learn more about the COVID-19. Okay, so hopefully that kind of helped to give a good explanation for that. Our notes are done. They need to be turned in. Like I said, you need to work on submitting one thing with all of your notes. I kind of gave you an example already. Now I'm going to see if I haven't turned this on since last school year. So, okay. For some of us, we're not sure. Yes, we can do scientific notation on the paper, but do you know how to type it in? Okay, so I just want to double check to make sure that you're okay with typing it in as well. There's more than one way to type it in. I just want to make sure that you can do it one way. I do it only one way. I don't have down in my brain how to do it the other way. I know there is. And one thing that I will tell you all school year long is there's more than one way to be able to do that problem. Okay? And my way is not the only way. I'm not that kind of a teacher where you have to show it my way only or you're going to lose the points. I don't care if you do it your way, but here's the but. You show me your steps of you doing it your way, if that makes sense. Because if you do it your way and you come up to some problems, I can't help you if you don't show me your steps. So you can do it my way or you can do it your way. I don't care. But 7, just throwing it as an example. 0.23. Do not hit the times button. No. Second key, EE. That means times 10 to the 8th power. And that's the number. Written out in standard form, this is the number written out as scientific notation. One more time, just in case, if we're not that familiar with typing in scientific notation numbers. 2.62. Do not hit times 10. That's incorrect. You're going to get the wrong answer. And let me tell you, you haven't learned this yet, but I'm a person who likes to trick you. I'm going to try to trick you as much as I can and see if I got you. Did you pay attention? Because when you put times 10 to the blah, 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 and do the problem, and you get an answer and you think you got it correct, guess what? That answer is going to be one of the A, B, C, D answer choices. And you're going to see it right there. And you're going to be like, oh, D. Incorrect. I got you. You didn't do this correct. So let's pay attention. 2.62. Second key, comma, which is right above the 7. I know I have this pink one. You may have the black or the yellow ones. They're the same. Right here. The EE is what I'm trying to get to. To the 4th power equals 26,200. Wait a minute. 5.21. Second key, comma, negative third power equals 0.00521. Okay? So that's how you do scientific notation in your calculator. I told you I wanted to show you, so there we go. At least we went through that. Make sure that you have a calculator and that your calculator works. If not, you need to check one out with Miss Wadding, okay? Other than that, we're done. We will see each other soon. Don't forget you have homework 1 and homework 2 due. Have a good day.